Welcome back to C# application development. We're kind of working through persistent stuff in Microsoft SQL Server this week. And where we left off last time is I had this semester table, and in my semester table I have some data. And this data mimics exactly what we used to have in our DB mock class here. I just added some additional rows just to test things out. So what we're trying to do is we're trying to get rid of this static class in favor of a database table or database structure with multiple tables in it that's going to allow us to store data that will persist even if the service is restarted, even if the server is taken down and the application is migrated somewhere else. This data will remain until somebody deletes the actual database file. So in the last video, what we did is we went through really kind of rudimentary SQL commands, what updates and inserts and deletes look like. You're not going to necessarily have to have a lot of knowledge about those things because we're going to end up using EntityFramework in the next video. But what this video is going to do is kind of serve as a bridge between the SQL stuff that we did last time and the EntityFramework stuff that we're going to do next time. And how we're going to do that is look at what's called the SQLClient library. So it's important that we're starting here in the database. I have a table, it's called semester. I have these semesters. If I go to my application in Visual Studio and I run it, after some period of time, I will get my results. And if I look at these results and these results, I see that fall 2019, summer 2020, spring 2021, fall 2020, and summer 2021 is what I get back. And that's exactly what's in the database. So that's great. So the question becomes, how did we link the stuff that we did in the database to the JavaScript code that we were previously using to read the static class? So again, we go back to the EC. So at the end of last module, we talked about how the EC is basically a non-static, stateless class. And that class, it basically just implements all of the business logic that you need to interact with the communication layer, which is the API controller that has the GET request, the POST request decorators on it, and the actual persistence component, which in this case is a database. So we have added some more complex stuff in this version of the application that I'll also put on Canvas, and so you can kind of do a side-by-side comparison of what's happened. But basically I've created this base EC. And what base EC does is it kind of breaks the rules. Base EC actually does have some state in it, but this state is basically just a connection string to a database. And it has a minimal amount of information, and it is sort of freely available to anything. It's never going to change because I only have a getter. And it's really just my laziness is the reason why this is here. So it's kind of breaking the stateless concept of an EC, but in some cases that's okay. You might need to store some state, but you want to be as close to stateless as possible. So what this is doing is this is providing a link out to my SQL Server instance. And so here my SQL Server is running on dot, which is localhost. You can also type localhost here. I have to give it a database, which is avet_db. And this trusted connection equals true bit means that I am logging in with the Windows credential. I'm not actually supplying SQL Server anything in terms of a username and password. If you were to supply a username and password, you obviously would not want to put the string in sort of plain text here. You would want that encrypted somewhere and to decrypt it in use, because you wouldn't necessarily want people to be able to decompile this code and then get the username and password. But this base EC has this information because all of the ECs for semesters and for classes and for instructors and for whatever will want to have access to this connection string so that they can use it to access the actual database. So if we go back to semester EC, this get method is previously what we were using to sort of go to dbmock and pull all of the semesters from that static classes property. What the get method is doing now is it's actually using this thing called a SQL connection. And in order to establish a SQL connection object, you have to pass it a connection string. And in this case, the connection string is coming directly from the base. We don't have to have that copied to every ECE for semesters and courses and whatever. So here we see that we're using again. So we talked a little bit previously about how there are managed and unmanaged resources. SQL connections are a great example of an unmanaged resource. So if you do not have this using statement here and you forget to dispose the SQL connection, it will persist, it will hang around for a long time, and potentially it will start degrading the performance of your application, because you will just have a ton of outstanding SQL connections that you're not even using anymore. So again, the biggest use case in which that could actually happen is if you have a try catch like this one, and you don't have a finally that disposes this connection. And so if you have the dispose inside of the try, you hit an exception and go into the catch, you can jump over the dispose, and at that point you're leaving a bunch of SQL connections hanging out. So there are a lot of different ways that you can use SQL connection to actually issue SQL commands to the database. In the case of get, I'm literally just sending over a query. So if I were to go back to SQL Server, this is my query that I'm executing here. Execute. That query is literally just the text for my SQL query. In addition to SQL connection, what I want to do is I want to create a new SQL command. That SQL command is going to take a string that is the query that I want to run. It's also going to take the connection, so it knows where to actually run that command against what database, against what server. And then I'm going to open the connection, and I'm going to call what's called ExecuteReader. So what ExecuteReader does is it sends you back a linked list style object. And what you can do is you can use the reader.read method to continuously read that result set until you're out of rows. So basically inside of this while loop, I have some processing going on, and each time I go through this while loop, I am iterating over each of these rows. So you can think this is the first time through, second time, third time, fourth time, fifth time, etc. So inside of that while loop, as I'm iterating over these rows, what I'm doing is I am creating a new semester DTO for each of those rows. And reader is going to expose to me the current row in the processing cycle. So that's the currently pointed to aspect or component of the linked list. And these things are all of type object, and they give you the ability to index using the column name. So if you go back over here, this is the column name ID, name, last modified. I can call into these with ID, name, or last modified. Now remember, we don't have a last modified on semester DTO because it's in the database. We don't actually care. So we don't have to call into that one. We can leave it off, and then the next time we go through, we'll just get to the next row, and the next row, and the next row, and the next row, etc. So after I have filled that result list, I'm passing that list back. That list goes back to the Java controller, and in the Java controller, I am setting my semesters to my response data, and now this data is still a list of type semester DTO. And so when I get the callback, I will have exactly what I had in the database expressed as DTOs, so I don't have to pick up the last modified or whatever columns I don't want. And it kind of just works the way that you would expect it to work. So the important thing to notice is we didn't actually have to do anything to this at all when we started making changes to change the EC A to return DTOs instead of just regular models. And when we changed it to use the SQL client instead of just a call to the static method or the static class. So what you want in these kind of multi-tier decentralized applications is you want changes in one layer to affect other layers as minimally as possible. And that's why you don't necessarily want to make changes here and then have to change a bunch of stuff in the JavaScript controller. So that is what the Git looks like. And we can go through these other ones, and I've changed all of these to use SQL connections instead of the link queries we were previously using. So here, what we're doing is we're doing the exact same thing, except we're passing in an ID. So we're doing exactly the same pattern. We're going and we're creating a query as a string. We're passing that string to the database. And in this case, we're using an interpolated string, and we're passing in the ID from the method. So this is a GET request that passes in an ID, and I can pass that ID over to the database server by using a string interpolation. Result processing is exactly the same. Search seems like it would be much harder, but it isn't. So we can use the SQL-like keyword, and what this is doing is it's replacing the contains logic in our previous SQL query. So here we've got basically an order by last modified to show that you can use last modified even though we're not going to actually use it in the creation of our DTOs. So this should also be fairly straightforward. It's just another example of how to use things. So everything's kind of fun and games until we get down to add or update. So add or update is where we're going to show how maybe SQL command and SQL client stuff is not necessarily the best way of doing things, and EntityFramework is going to give us a lot better way of handling things. So in these multi-tiered applications, the biggest issue around data management is trying to synchronize IDs, and we've alluded to this several times in videos. What that means is when a user goes out and creates a new semester, they are either going to have to get an ID on the client side and pass that ID into your server-side logic and then persist into the table with an ID, or they're going to have to not get an ID on the client side and get an ID on the server side. So you can do it either way, but getting an ID on the client side is really, really hard. And the reason is because you could have 5 to 10 or 15 or 500 users that are getting IDs, and you have to make sure that their IDs don't collide. So if I create a semester at the exact same time that you create a semester, I have to verify on all distributed clients that I am getting a different ID than you are getting. Otherwise, what's going to happen is we're going to go to the database and we're going to try to insert a record with the same primary key value, and it's going to blow up. So the traditional way of handling this is to have all IDs be either a negative number on the client side or be a 0 on the client side. And then when you pass it into the server-side code, what will happen is the server-side logic will say, hey, is this ID bigger than or less than 0 or equal to 0? And if it's greater than 0, that means that I've received an ID for this entity before. Traditionally, that ID management is done in the database using the identity concept that we talked about last time. So every time you insert into the table, you'll get an ID back. You'll pass that ID back to the client, and then everybody is kind of happy. You have a positive ID, and then the next time you save that entity, it will go into the update, whereas before it would go into the insert to be assigned an ID. So that is what this logic is doing. It is trying to, this logic and the else. It is trying to understand if it needs to call the update store procedure that we made in the last video, or if it needs to call the insert store procedure that we made in the last video. If I already have an ID, that means I've been in the table before, and that ID should match exactly one record in the database. And so what I'm doing is I'm passing in the new name of the semester, and I'm passing in the ID of the row to update. If I don't have an ID, what happens is I perform an insert, and then everything's fine. I insert the record, and then I jump out and I go back. So we can try that out by doing add, and then we can say I want to add fall 2021, for example. I want to say OK. And then if I go to my database and I select Now I have fall 2021. And so now I have a situation where I have a UI and I'm passing requests via button click all the way down spring 2022 through the server-side code down into the database and back. So this is great. I mean, this is the first kind of fully point-to-point or end-to-end data management exercise that we've done. So now let's talk about the problems. So the large problem is that if you look at the code, I am not actually returning anything reasonable here. What I'm doing is I'm passing in a semester, I'm inserting the semester's name, and then I'm passing that semester back. I don't do anything with the ID of the semester. So if I come back over here and I try to click spring 2022 and I try to add something like a class code, let's see, English 101 or whatever, great, it will be accepted, and now that is a part of the static classes list of courses. The problem is that I can't get back to it because the ID on spring 2022 is 0 still. I never updated it on the server side. So this brings up the great question of how do I actually assign and then pass back that ID. So if I go to my SQL again, and I go to the store procedure for insert, and modify that thing, all I'm doing is that I'm inserting into the table and I'm passing in a name and a last modified, but notice I don't have an ID. So from a multi-threading perspective, I could be using the table and you could be using the table, our 500 friends could be using the table all at the same time. We're doing a massive number of updates. Potentially this isn't a semester table, this is a time entry table, this is a transaction table for a bank. And so there are thousands and thousands of transactions every second, and we can't do something cheeky like selecting top one or selecting the top record, ordering by last modified descending, because potentially by the time I perform that select, 5 or 6 other people have inserted something into the table. So trying to deal with IDs and passing IDs from the database layer back to your server-side code is non-trivial. The sort of traditional way of handling this is to have a separate table entirely and have that separate table keep track of what the latest or the last and the next key for each table is, instead of using the identity. So what you would do if you wanted to use the SQLClient way of living, you would have a different table named potentially unique keys or something, and then that table would have a row for every table. So there would be a semester table, and that table would have columns, and one of those columns would be what the next primary key is. And when you get that next primary key, you would want to do that through a store procedure, and that store procedure would update the next key in the database table to reflect the next key. And so what you're doing is you're implementing our original logic from the JavaScript, this next semester logic, where if you go down to this, basically what you would do is you would call a store procedure in the database to get the next ID. That same store procedure would go to your unique keys table and increment the next ID by 1. And so every time you pull an ID, only you can pull that ID, and it doesn't matter if anybody else is using the table at the same time. They'll just get the next ID and the next ID and the next ID. So basically you're just provisioning IDs, and if you don't use the ID, it doesn't actually matter, you just throw it away. That's one way of doing it. It just requires an additional table. There's quite a bit of additional overhead there, and it's just additional work. Nobody really likes additional work. So what we're gonna show in the next video is that EntityFramework actually handles all of that stuff for you. So you can have an identity column on your table, so you don't have to manage IDs on your own. And so if you look, remember, we don't even have to put an ID at all into the insert because the ID is generated in the table. EntityFramework will do all that stuff for you, and then it also allows you to do add or update kind of seamlessly, and it handles all the ID linking, so you don't have to do it manually. However, if you want to do it manually, you kind of need a second table, and the second table is going to do all of your ID mapping. So one additional kind of weird thing is if you select the semesters, we get them in the order that they were created. So these are not necessarily in the order that you would reasonably want them if you're going to try to show them in the list here. So one way that you can do that to kind of fix that is you can add a column to the database that allows you to order on that ID, and then you don't have to worry about manually sorting it on the server or something like that. So how you add a column to a table after the fact, so after you've already created it, is you use an alter table statement. It's going to be alter table, name of the table you want to alter, add, name of the column you want to add, and then the data type that you want to add. We can also make it null if you want. So if I run this and I select, now I have this additional table, or this additional column on the table. If you go to the UI here, and you go to the semester table, you can right click and go to edit top 200 rows, and then we can sort of fill this out. So fall 2019 is the first one. We don't have any other 2019s, so summer 2020 is going to be the next one. Fall 2020 is going to be the next one. Spring 2021 is going to be the next one. Summer 2021 is going to be the next one. Fall is going to be the next one, and then the next one. And so then we save that, close, and now if we run, we can order by order number. And so now this is in the order that you would kind of hope that things would come in into the UI. So we can easily go back over here to our get method in the EC. Select star from semester, and we can do order by order number. Order number. You can save that and run it. And so when I get the response back from the database, it'll be in the order that I expect it to be in. So fall, summer, fall, spring, summer, so on and so forth. So this is another example of a column that you could certainly want in the database, but you don't necessarily want to send over in the DTO. So notice we were able to use this column without modifying any classes. We didn't care at all. We were just able to use this in the SQL. And so by virtue of having access to it in the SQL, we were able to order things and then send the list in the correct order back to the UI with very minimal changes. And that's, again, what you kind of want to see in a tiered or a layered application. You want to make sure that changes in one application don't necessitate a change in another layer of the application if you can at all help it. So that is the long and short of SQLClient. Notice that I have one extra method down here for removal. It follows the exact same pattern, delete the semester where the ID is something, but also notice that now I don't need the concept of remove by ID because I'm really doing it by the semester. So this is largely a code clone of this. I could just supply an override here that has just the ID, and really quickly I'll show how to do that. Would be public bool remove int ID, and so we would have all of this stuff. in here. But this would be the ID. We need that. So what we've done is we've made a new override of the method that takes in an int ID. And we have changed the semester.id to only be semester. And now we can say return remove on semester.id. And we're done. And we don't have to have this anymore. So we don't have to copy code around all over the place. This is often referred to as a method override hook. The reason being we are reusing 99.9% of this code by calling into one override from another. This is kind of a key technique when you don't want to break the interface of something. So let's say that I had always supported int ID as the parameter. If I want to add a new parameter semester, I could do that, and I could establish the same behavior by using an override like this. So that kind of illustrates kind of how you can modify things, and you can also get rid of code clones as you kind of advance the architecture that you're using. So originally we were using a static class. The static class was really just a bunch of link and whatever. Then we migrated to a database, and now we're kind of using the most naive version of a database implementation. We're basically just using raw SQL being sent across a connection to the database server. That said, you'll notice for the update and the insert, this is something I forgot to bring up. I am not just sending a command over. What I'm doing is I'm actually saying that the command is going to be of type stored procedure. So I'm giving it the name of the stored procedure as the SQL bit, and then I'm adding these parameters. And so these parameters match the names and the values that are expected by the parameters. So if you go back over here, I have a name parameter for insert. And if you look in here for insert, I have a name parameter. The reason why we do this is because if you just typed out the exec blah and then passed the parameters in, you're exposing the parameters. And SQL parameter injection is like a very common kind of hacking vector. And so this is a more secure way of executing a stored procedure on a remote server. This stuff is going to be encapsulated as it's sent over. So you're not going to be exposing parameters to anybody. You're not going to expose to them a SQL or piece of SQL that they can easily inject things into. So that's the reasoning behind why this is different from each of these reads up here. We're not actually doing a whole lot. These aren't writing, they're actually just reading from the database. So the worst case scenario is that you would get things that you don't expect. And you could certainly replace these simple queries with stored procedures. I just wanted to kind of illustrate how you could do both. It's kind of an either or situation. So that's gonna wrap it up for SQLClient. And so in the next video, what we're gonna do is we're gonna actually map or model this table over here with EntityFramework, and then we're gonna allow EntityFramework to do all the heavy lifting in terms of ID synchronization for us. And at that point, we will have largely just a full stack application at that point, where you have a UI that's able to allow a user to generate data. You have a web API controller that is able to communicate with that client, pass it through an enterprise controller that does any of the sort of business logic, validation kind of stuff that you need, and then passes it off to EntityFramework, which will be our new persistent store. So thanks for watching. I hope this is kind of coming into view, and I look forward to doing the next video. Thanks.